This is part 9 of the series, The Basics of Geometry, and we're going to start this session with a new postulate called the angle addition postulate. It's very closely related to the segment addition postulate, in which we had given a segment made up of multiple parts. The overall segment is equal to the sum of the lengths of the parts that make it up. Well, the same is true for the angle addition postulate. Here we have angle ABC, which is made up of angle ABD and angle DBC. So it simply says the measure of angle ABC is equal to the measure of angle ABD plus the measure of angle DBC. So if point D lies in the interior of ABC, then the measure of ABC is equal to the sum of the measures of ABD and DBC. And we're going to use this postulate in conjunction with a couple of other ideas, and one of those being the ideas of congruent angles. Now, as related to congruent segments, two angles are congruent if and only if they have the same measure. In congruent segments, we know that the definition of congruent segments is two segments are congruent if and only if they have the same length. Here in this picture, we can see that the measure of angle A is 20 and the measure of angle B is 20. Therefore, since the measures of these angles are equal, the angles are congruent. So we'd say angle A is congruent to angle B, and we would write the measure of angle A is equal to the measure of angle B. Likewise, in this picture, we see by these little arcs that these two angles are congruent. These arcs in the interior of the angle mean that angles are congruent. There could be 2 arcs in each, 3 arcs in each. Whenever you match up these arcs, you'll know that those two angles are congruent. Now, there may be times when you see these arcs inside of angles and it's not implied that those angles are congruent, but it'll be fairly obvious from the statement of the picture that you're given whether that means that these angles are congruent or not. So here, because we're shown in the picture that these two angles are congruent, we can write the same thing. Angle 1 is congruent to angle 2, and therefore by the definition of congruent angles, the measure of angle 1 equals the measure of angle 2. And this leads us to the idea of angle bisectors. So in this picture, very similar to this, we have two angles here that have these congruence marks. That tells us that angle PQR is congruent to angle RQS. And if these two angles are congruent, that makes ray QR a bisector of angle PQS. And just as with segment bisectors, a line, ray, segment, or plane that divides a segment into two congruent segments is a segment bisector, or one that passes through the midpoint is a segment bisector. Here, a line, ray, or segment that divides an angle into two congruent angles is an angle bisector. So this ray is dividing this big angle into two congruent angles, therefore ray QR is an angle bisector. And because angle PQR is congruent to RQS, we can say the converse, that ray QR is the bisector of angle PQS. Now this leads to yet another concept. Notice that we have two congruent angles here that are joined together in a specific way, and here we have two congruent angles that are not joined together. These two pictures are similar. We have two angles that are joined together here, and these are not. We're going to call this pair of angles and this pair of angles adjacent angles, and that's the topic of our next discussion. Adjacent angles are two angles that share a common vertex, share a common side, but have no points in their interior in common. So any point that I make over here, it's only going to be in this angle and not over here. And likewise, any point that I make over here is going to be in this angle and not in this angle. Now, it is possible to violate one or both of these, and you can see how those angle pairs would not be adjacent angles. Here's the first example. In this picture, we have this angle, and they both share a common vertex. So that matches the first condition. But there is a point here that is in the interior of both angles. Notice how this point is in the interior of this angle, and that point is also in the interior of this angle. Also note that the second condition is violated. These angles do not share a common side. So just because they share a common vertex does not mean that they're going to be always adjacent angles. So these two angles are not adjacent because they violate the common side rule and they violate the point in the interior rule. Now for our next example, we have only one rule being violated. Here we have two angles that share a common vertex, and they happen to share this side. But notice this point is in the interior of both angles. It's in the interior of this angle and in the interior of this angle. Therefore, even though these have two of the three rules, it violates the third rule. These two angles do have a point in common in their interior, so these angles are not adjacent angles. So let's go ahead and put these ideas together and see if we can solve some more practical problems. In this problem, we're given that the measure of angle PQR is 165 degrees. We want to find the measures of angle PQS and SQR. Now they give us the expression for PQS, which is 2x plus 3, and the expression for SQR, which is 3x plus 2. Now please don't make the assumption that even though this looks like a right angle, don't make the assumption that it's a right angle. Never ever trust the picture. That's rule number 1 in geometry. Never trust the picture, only trust the information given in the picture. So the only thing that we know that's true is the angle addition postulate, that the measure of angle PQR is equal to the measure of PQS plus SQR. So that's what we're going to write to start off our problem. The measure of angle PQR equals the measure of angle PQS plus the measure of angle SQR. We know that PQR is 165, and that equals PQS, which is 2x plus 3, plus 3x plus 2, angle SQR. Now it's just an algebra problem. 165 equals 2 plus 3 is 5x, 3 plus 2 plus 5. We subtract 5, 160 equals 5x, 32 equals x. Now to find the measure of angle PQS, we have 2 times x is 32, so we put that in there, plus 3, and the measure of angle SQR is 3 times 32 plus 2. So this is 64 plus 3, which is 67. And this is, that's 96 plus 2, which is 98. And we better hope that 98 plus 67 is 165. So this is 150, 150 plus 15. Yes, it's 165. So we got it right. Let's move on to the next problem. In this problem, we're given that angle ABC is a straight angle. ABC is a straight angle, which means that the sum of these two angles is 180 degrees, because a straight angle has a measure equal to 180 degrees. And we're looking for the measure of this angle and the measure of that angle. Now I'm not going to bother with the long statement of this plus this equals that. I'm just going to write down that we know that angle ABC, which is 180, equals this angle plus that. That's angle addition postulate. 3x plus 7 plus 7x plus 3. 180 equals 7 plus 3 is 10x. 7 plus 3 plus 10, that's nice and convenient. Subtract 10, so 170 equals 10x. Divide by 10, 17 equals x. So that makes the measure of angle ABD equal to 3 times 17 plus 7. We just substituted 17 in for the x here. And the measure of angle DBC is 7 times 17 plus 3. So this is going to give us 58 degrees. And this is going to give us 122 degrees. All right, let's look at the next problem. In this problem, the only thing we were given is the picture. And in the picture, we're shown that this is a right angle symbol. That means that angle LMN has to equal 90 degrees. So we're going to say that 90 equals, this is very similar to the last problem, except that was a straight angle and that was equal to 180. So the sum of these two angles is going to equal 90 now. 6x plus 12 plus 2x minus 2, not 3. All right, 2 plus 6 is 8, so 90 equals 8x. 12 minus 2 is 10. Subtract 10, 80 equals 8x. Divide by 8, 10 equals x. Now let's go ahead and say the measure of angle LMO equals 6 times 10. We're substituting a 10 in for the x, plus 12. And the measure of angle OMN equals 2 times 10 minus 2. So this is 60 plus 12, which is 72. And this is 20 minus 2, which is 18. And that equals 90 degrees. And now for one more problem. Here we're told that ray AY bisects angle EAS. That means that angle EAY equals angle 8 YAS. So 12x minus 4 equals 8x plus 20. So 12x minus 4 equals 8x plus 20. Subtract 8x. 4x minus 4 equals 20. 4x equals 24. X equals 6. Now to solve the measure of angle EAY equals 12 times 6 minus 4, and the measure of angle YAS equals 8 times 6 plus 20. Now these are going to have to be the same. So 12 times 6, that's 72, minus 4, which is 68. And that's 48 plus 20, which is 68. And we got it. We have just a couple of topics left in this series, and so we'll cover those in the next video. So I will talk to you in the next video.